plane pi contains point A, we have a 4, 1, 0. And it is perpendicular to L1. So let's say L1 is here, L1. And L1 is this. So I know the equation is this. So we are supposed to find the equation of the plane pi. So for plane pi, for L1, which is supposed to be perpendicular to the plane pi, this is parallel to this 1 minus 1, 2. That's what we have learned theoretically about the equation of a line. So we take that, put it into here. So from this, I can see that the normal to the plane pi is this, and it passes through this point. Okay, it is an easy question. I just want to go through the full problem-solving process together with you. I see the scenario first, then I try to apply the theory. So I've seen the scenario clearly already. The theory is easy. The theory is usually repeating. So pi is r dot the normal vector 1 minus 1, 2 is going to be equal to the position vector of a point that is on the plane, and I have that 4, 1, 0 dot 1 minus 1, 2. If you were to evaluate this, 4 minus 1 plus 0, this is going to be equal to 3. So I have another piece of information. I'm going to just write it here. It is pi is r dot 1 minus 2. This is equal to 3. For those of you who are already very comfortable in drawing diagram, then doing vectors, I also want to believe that you have less problem with vectors. But for those of you who have always been having some problem with vectors still, although every time when you listen to me talk about magic triangle, you get it. Every time when you look at the equation of a line, you get it that r is not the line. R is the position vector of a point that is on the line. Same for a plane. If you get all this right, maybe what you are really lacking is that few seconds of pausing and then trying to draw or understand the scenario. Next, part 2. Find the coordinates of the point P that is on L1. Find the coordinates of point P that is on L1 such that AP is perpendicular to L1. Okay, let's look at this from two different perspectives. Okay, so I'm going to do it using my first, using this first method. I'm supposed to find the coordinates of point P such that AP is perpendicular to L1. The first method, which I think I will probably be using that in the exam also, point A is here, and the line L1 is here. According to the description that is given to me by the question, point P is going to be this, right? Because the question says that AP is perpendicular to L1. In fact, after I've drawn this diagram, I can see this as something that is familiar to me according to what we have discussed in our outline. What is the same scenario? I mean, the description can be different. Like what I was telling you, they will always tell you scenarios that are going to be a bit different. That's a style of vectors. The aim is for you to think. The aim is not for you to just dispense the theoretical portion. So what is this synchronizing to? According to what we have learned in our processes, pre-learned in our processes, foot of the perpendicular, right? This is a foot of the perpendicular question. So, okay, this is a foot of the perpendicular question. I'm going to just do this as foot of the perpendicular. It is the same old process. I'm going to be repeating. So foot of the perpendicular, first of all, P is going to be a point that is on line L, which means that OP is going to be this. So OP is going to be equal to this since it's a point that is on line L. So it's going to be 3 plus lambda minus lambda, 3 plus 2 lambda. OP is this. And the question says that AP is perpendicular to the line L1. So I'm going to try to find vector AP first. AP is going to be OP minus away OA. So this minus away OA. OP minus OA, this is equal to minus 1 plus lambda, minus 1 minus lambda, and 3 plus 2 lambda. AP is this. And since AP is perpendicular to L1, and we know that R is not L1. Okay, for those people who didn't manage to understand the theoretical part of this line, sometimes they will actually take this, then go and dot the entire R, which is incorrect. So from here, I will extract out the vector that is actually parallel to L1, which is 1 minus 1, 2. And I know that AP will also be perpendicular to this. So I'm going to take AP dot this 1 minus 1, 2. And I'm going to be letting this be equal to 0. So we have a minus 1 plus lambda minus 1 minus lambda, 3 plus 2 lambda, this dot 1 minus 1, 2, letting this be equal to 0, working out the value for lambda. Lambda is going to be equal to, here, lambda is going to be equal to minus 1. Therefore, we will be able to find OP. OP is going to be equal to 3 minus lambda, positive 1, 3 minus 2. So 3 minus lambda, lambda is minus 1. So OP is going to be equal to 2, 1, 1. And we are not going to leave our answer as 2, 1, 1. Like what I was also telling you that next year your schools are going to be very strict in terms of you following instructions that are given to you by the question and you're doing good presentation. So what is wrong with this? The question is asking us for the coordinates of point P, not the position vector of point P. So I do want to make sure that I give my final solution in the coordinates form 2, 1, 1. This is if we were to do it as a foot of the perpendicular scenario, okay, which is good. In the exam, I will probably do this also. Okay, in the exam, I will do this. So this is a good solution, exam friendly. I want to show you another possible way to find P. This other possible way is shorter. This other possible way is shorter, and it will definitely be deriving for me the same answer. But this other way is probably not something that I will try to do in the exam because it's going to be a bit more unfamiliar. So it is more of like for our discussion now, not for the exam, but we must understand, okay? The more I try to expose myself to something that is a bit more unfamiliar as I do my revision and practice, that means I will have one less unfamiliar thing to face during the exam. So I do want to try that with you, and it is still important, okay? Although this is good, this is familiar. In the exam, I'll probably just regurgitate this the moment when I realize that this is another foot of the perpendicular question. Okay, but you know this, the intention of this question here, right? How I wish, okay, but SAJC didn't do that, which I think is good, because if they were to plant in an extra word here, right? Hence. Part 2, if they were to just say hence, find the coordinates of P. You know how many more students will not be getting this correct? Hence, if they were to say that. This is if they were to not say hence. So once you read very casually, just this line, just reading this line, right, and you synchronize it to foot of the perpendicular, you should be able to get it correct already. But the moment when they say hence, my solution is not going to be very difficult to understand because the solution is still going to be a repetition of how you usually see solution and understand vectors by reading notes and stuff. Okay, but the moment when they say hence, what they need you to do is pause and think. Analyze the scenario first. Okay, so let's try to do that, okay? Let's not look at part 2 as a standalone. Let's look at part 2 as a whole. So as a whole, we have the line L1. We have the point A. And AP is such that it is perpendicular to L1. You know, in this diagram, we have the line L1. We have the point A. And P is a point that is on L1, such that AP is perpendicular to the line L1. So can you imagine also that this point here is actually the point P? If you don't just look at it as an independent standalone part, if you look at it based on the previous, this is the point P. Just in case you are not able to see why this is point P, when we draw diagram, we should try to draw 2D as much as possible because it's easier. Okay, but if 2D doesn't work, let's try to go for 3D. So let's try, okay, let's try to do a quick sketch of this in 3D. So if let's say I have a point, I have a plane pi here, and according to the first part, we know that plane pi is going to be perpendicular to L1. So this is 90 degrees perpendicular to L1. And we have a point A that is going to be lying on the plane pi. The question says that AP is perpendicular to L1. AP is perpendicular to L1. If you were to be required to plant P here, let's ask ourselves now, where do you think P is? If I were to plant P here, where do you think P is? If this question were to be a hence question, which means that from a standalone question, from a standalone part, you need to try to associate it to the previous part. Where do you think you will plant P? You will plant P here, on pi, point P, such that AP is perpendicular to L1. Because if L1 is perpendicular to the plane pi, any line that is on the plane pi will also be perpendicular to L1, correct? And if A is a point that is already on the plane pi, the only place that P can lie in order for AP to be still perpendicular to the line L1 and is on the line L1 is here. If I were to plant P anywhere else, AP will not be perpendicular to the line L1. Okay? And this, after this, then the solution is going to be repeated. But this can never be learned through you just keep looking at the theoretical portion of vectors. You go and read your notes so many times, right? You will still not be able to do this. This can only be done by exposing yourself to an unfamiliar situation and then try to develop the habit to want to decrypt it, to want to understand the scenario. And understand the scenario is not difficult. It just requires you to pause and think, to spend that few seconds, which like what I was telling you, I believe some of you didn't spend that few seconds to think. The way you look at this question, if it is a hands question, your aim is to want to write some stuff. Vectors is not a topic that is supposed to be done this way. So once I've understand this, P is actually just the intersection between L1 and pi 1. And L1 is this. R is equal to 303 plus lambda of 1 minus 1, 2. Pi is r dot 1 minus 2, 3. This is equal to 3. Once I've understand this, I'll ask myself, what theory have I learned before that can help me to solve for the intersection between geometry? What is the theory that can help me to solve for intersection between geometry? Simultaneous equation. We have learned that since our secondary school. Every time when physical geometry intersect, that is where the points of intersection is simultaneously satisfying the equation of the two geometry, solve simultaneous equation. So I'm going to treat this as if it is equation number 1. I'm going to treat this as if it is equation number 2. I will sub equation number 1 into equation number 2. So if I were to put equation number 1 into equation number 2, it is going to be 3 plus lambda minus lambda, 3 plus 2 lambda, putting into this 1 minus 1, 2. This is equal to 3. Solving for lambda, lambda will still be equal to minus 1. Then I'll sub it back into here to get OP. And it will be 303 minus 1 time of 1 minus 1, 2. And I will still be able to get a 211, which gives me the same coordinate of 211. We will pause and think. Let's try to pause and think again using this last scenario, last part of the question here. So far, any question? Okay, this is part of my solution. This is not just something that you want to hear it being explained to you by the teacher. It is part of my solution. It is a critical part of my solution. I'm going to draw it onto my script. Okay, but sadly, your diagram is not going to count in terms of the marks that you have gotten. Okay, diagrams will usually not be counted unless the question asks you for it. For very seldom vectors, they ask you for a diagram. So this is the part where you're going to start getting marks. Okay, that is why for us who are so practical, right? Sometimes you really ignore that this is valuable. It has value. It's just not giving you that instant value, but it has a lot of value in terms of solving problems. So let's take a look at the last part, and we want to aim again, okay, to draw diagram. The last part is about reflection. A student is investigating the effect of reflecting a ray of light in the plane pi. Okay, we are still looking at the plane pi. The ray of light travels in the line L2 from the point 0, minus 9, 1 to P. Where is P? P lies on the plane pi. Right, just now we have already drawn that diagram and we have determined that P is a point that lies on the plane pi. Again, just imagine, okay, if I didn't draw that diagram and I adopted the more standard process to find the foot of the perpendicular, even in this last part, you will still need to be able to visualize that P is a point that lies on the plane pi. And it's very, very difficult to ask a teacher, how do you know that P lies on the plane pi? Expecting the teacher to give you a theory of why P lies on the plane pi. We want to seek to learn, but we don't want to try to learn from things that we are supposed to learn it through experiencing it ourselves. Because it is impossible for somebody to tell you exactly how that is done. So we are trying to understand the scenario. Drawing the diagram is really, really going to be crucial. And based on what we have found previously, P has a coordinates of 2, 1, 1. And this L2, according to what the question says, passes through a point. This point is 0, minus 9, 1. Okay, I'm going to call this point B, okay, B, because A is already given to me here. And the ray of light is reflected along L3. So here, reflected along L3. It's reflected along L3 in the same plane as L1 and L2. What is L1? L1 passes through the point P. And L1 is perpendicular to pi. So we have this. This is L1, which is going to be perpendicular to pi. And according to what the question says, L1, L2, L3, they lie on the same plane. And it is now also given to me, just in case my physics really cannot make it, that the angle between L1 and L2 equals the angle that is between L1 and L3. So this angle here is the same as this angle here. This is the information that is provided to me by the question. And what I'm supposed to do is to find this. Okay, I am supposed to find the equation of L3. L3. And I know how the equation of L3 looks like. It is going to be R is equal to, because it is a line, plus let's say mu of something else. Okay, let's say we have the equation of the line as this. Did I use mu previously? No, I didn't. Okay, I'm going to use mu. So I know the equation of the line L3 is this. And I can already see from my diagram that L3 passes through this 2, 1, 1. So here is already 2, 1, 1. What I actually need to find now, right, is this. A direction that is supposed to be parallel to L3. Then I will be able to answer this question. It is a 6 marks question. After we have finished solving this, the solution is nothing spectacular because it is just a repetition of what we have already discussed previously here. Okay, you will see this happening. In fact, if you were to go into the video, you will see the numerical example of how this is going to be happening. So the solution is nothing spectacular. The diagram is the one that is the most crucial. The diagram is important. We want to make sure that we understand the scenario first. Draw the diagram. If you don't have the discipline to pause and think, draw the diagram. It will discipline you to pause and think. But let's say, okay, we're going to do not the best and ideal way to do exam, but I'm going to show you the power of you understanding the scenario first, assuming that you have put in effort to understand the theory before the exam, okay? So let's say I draw the diagram. I've already drawn the diagram, it is this. Okay, and from the diagram, at least I can associate this scenario, right, to a reflection scenario. Okay, and reflection scenario happened to be one that I've studied before the exam. So I do know the process of reflection. Then according to this, right, we are supposed to locate the foot of the perpendicular of a point to the line or the plane. Usually it is the line or the plane that the point reflects about. So looking at the scenario that is here, which one should I pick as the point? Okay, I've mentioned to you before, so whichever point that you pick, it is up to your own judgment based on the scenario. So here, should I pick this point? No. I pick this point. I don't know what to do with this point. So it should be this point. So if I were to pick this point instead, right, then the first thing that I'm going to do, although I don't really know what is going on, the first thing that I'm going to try to do is I'm going to try to find the foot of the perpendicular first, okay? So I'm going to just write down this part. I will try to find the foot of the perpendicular, which is going to be, since we have a process. What is the process? It is the foot of the perpendicular from the point B to the plane pi. So the process that we talk about is going to be here, the foot of the perpendicular from a point to a plane. Okay, so I'm going to just continue to show this for now, okay? So the first thing I'm going to do is I'm going to form the equation of a line that passes through BF. This line will be R is equal to, it passes through this point, 0 minus 9, 1, plus, I'm going to use mu, there's lambda here, so let me use, let's say beta. Beta of a direction that is parallel to this. What is the direction that is going to be parallel to BF? I can use the same direction that is parallel to L1, which is perpendicular to the plane. So this is parallel to this. So here I'm also going to go for 1 minus 1, 2. So here 1 minus 1, 2. And what is this point F? It is the intersection between this line and the plane pi. So solving simultaneous equation at the point F, I will take the equation of this, put it into the equation of the plane pi. So this is beta minus 9 minus beta, 1 plus 2 beta. I'll put it into this. So this dot 1 minus 1, 2, this is equal to 3. If you were to work out the value for beta, beta here is going to be equal to negative 4 over 3, which I can substitute it back into here to find F. So therefore, OF here is going to be equal to 0 minus 9, 1 plus beta, then 1 minus 1, 2. OF is going to be equal to negative 4 over 3, negative 23 over 3, and negative 5 over 3, which I can definitely use it as it is. Okay, I should use it as it is. Okay, I need the point. I need the actual position vector of this point F. So I've already completed this when I actually have problem, applying, okay? I know the theory, I know the scenario, but my problem is the application part. Okay, but I'm going to just write this first because there's no better solution that should appear in my script as of what I am seeing right now. So I'm actually trying to get marks. Okay, not because I totally understand what is going on. So what is the next step? Next step is using ratio theorem to find the reflection of that point. Okay, this next part, you do need to do a bit of visualization, which is here. Reflection of this is, let's say here, I'm going to call this point B prime. And because it is reflection, this distance and this distance, they should be the same. So the proportion is going to be 1:1. If I were to reference everything to the origin, I can then make use of the ratio theorem to try to find B prime. So making use of ratio theorem, we know that OF is going to be 1 time of OB plus 1 time of OB prime divided by 1 plus 1, which gives me OB prime as this over 2 times of OF minus away OB. So it's going to be 2 times of this minus away OB, which is 0 minus 9, 1. This will give me a minus 8 over 3 minus 19 over 3 and minus 13 over 3. OB prime is this. And guess what? Because you have dispensed something from the theory, after you have understood that this is a reflection scenario, can you see how we can then find L3? If you were to look at this diagram again, can you see that if I were to just extend this line L3, it is supposed to be passing through B prime. If I were to just extend this, isn't it? I mean, how do I know that it is so? I mean, geometry tells me so. It's not because I read some theory here and there. Because I want to see the geometry of this to explain to myself how I can continue. Then, can you see that this angle is supposed to be equal to this angle? And by alternate angle, this angle is supposed to be equal to this angle. And that is why this line L3, when it is being extended, it should be passing through B prime. And this is what that is going to be helping me to fill in this gap here, because the next thing that I'm going to try to do is to find B prime P, which is going to be OP minus OB prime. OP is 2, 1, 1. OB prime is going to be this. If you were to evaluate this, you will be getting 14 over 3, 22 over 3, and 16 over 3, which is going to form for you the direction of L3, which you can also fill in here. Or else, I mean, this is the last part, so I'll probably just take this fill in here, okay? I don't want to waste too much time. But if you want to just make sure that your solution looks a little bit more user-friendly, you can also consider factorizing out, let's say, 2 over 3 from here, which gives you a 7, 11, 8. And then writing L3 as R is equal to 211 plus mu of 7, 11, 8.